Everyone. This video is going to walk us through step by step every single question on the first page of the type 3 both sides. So when I look at number 1, the question is, what is the solution to a system of linear equations? And if we recall from our very first day of working on systems, we said that a solution to a system is where those two lines intersect. This point of intersection right there is the solution. So it'd be nice to get a picture and words. So the solution to a system of linear, and I'll abbreviate, linear equations is where the lines intersect, that point of intersection. So in parentheses, I'll put that, point of intersection. And that's the biggest reason when we do an algebraic check where we take the ordered pair and plug it into both, the fact that it comes out true for both equations is what makes it true for both lines, this line and this line. If I do a check and my ordered pair is only true for one of the equations, it means that, for example, that ordered pair is on the first line and it's not on the second, or vice versa. So that is the biggest reason, well, it's the only reason, why when we check a point, it has to be true for both equations, because then it means that that point is on both lines. In other words, it's the point of intersection. Now, numbers 2 and 3 ask us to solve the system by graphing. Now, to solve by graphing, we have to remember a key approach for graphing. To graph a line, we have to have slope-intercept form. Need y equals mx plus b. So when I look at the system given to me in number 2, neither of these are solved for y. So we'll take them one at a time. Let's work on x plus 2y equals 4 first. How am I going to solve this for y? I'm trying to get this variable by itself. Well, when we're solving, if there's something that I could move over by adding or subtracting, we want to do that first. So when I look, this positive x, I can move over by subtracting x from both sides. I subtract x from both sides. That gets me 2y equals negative x plus 4. I'm closer. Now I just have 2y here, but am I done? No. We need to get rid of this 2. But to be able to know how to use math to get rid of this 2, I have to know what's actually happening here. Does this say 2 plus y, 2 minus y, 2 divided by y? What do you think? Well, if it was addition, I'd see a plus. If it was subtraction, I'd see a minus right here. If it was division, I would see this. I don't see any of that. So that means it's multiplication. When you see a number and a variable side by side, it technically is saying 2 times y. So what's the opposite of multiplying by 2? The opposite of multiplying by 2 is dividing by 2. So we're going to divide this piece by 2 and each term on the right by 2. 2 divided by 2 is just 1, so you can either write 1y or just y. Y equals. Question of the day, what does this get me? Well, in front of x, the coefficient is negative 1. Negative 1 is not divisible by 2, so we're going to keep it as a fraction. Negative 1/2 x. 4 divided by 2 is a positive 2, and now we have our equation. To graph this equation, we need to identify m and b. M equals negative 1/2 and b equals 2. this is where I will start at b equals 2. So I go to 2 on the y-axis, and then from here I know how to count. Negative 1 is down 1, positive 2 is right 2. So I will be counting down 1, right 2, down 1, right 2, down 1, right 2. And remember, the first line, we want to get as many points as possible. If I come back here, the opposite of down and right is up 1, left 2. Up 1, left 2. Up 1, and I'm just going to keep going. And we want to have a nice straight edge to make this line. The neater, the better. So either use your ID, or remember, taking a piece of paper and folding it into fours creates a nice straight edge. Should I have a decreasing line? Well, I look at this slope. I have a negative slope, so yes, I should have a decreasing line. My second equation says 3x minus y equals 5. Line down the equal sign, trying to solve for y. On this side, is there something that I could use math to move over using addition or subtraction? Yes, we can subtract 3x from both sides. Subtract 3x. This cancels, 0. That leaves me with negative y equals negative 3x plus 5. Is this done? Well, y looks like it's almost by itself, but not quite. What's out front that we need to take care of? This negative represents a negative 1. So we will divide each piece by negative 1. So now I have y equals negative 3x divided by negative 1 is a positive 3x, and a positive 5 divided by negative 1 is negative 5. And now we're done. So identifying m and b, m equals 3 divided by 1, b equals negative 5. This is my starting point, so I go down 1, 2, 3, 4, 5, and we're going to count up 3, right 1. I'm going to move this down here. I don't want us to confuse it with that line. So from negative 5, my y-intercept, I'm going to follow the directions from that slope. I'm going to count up 1, 2, 3, right 1. Up 1, 2, 3, right 1. There's my point of intersection. And might as well go for one more point. Up 1, 2, 3, right 1. And we'll use our straight edge to draw our line. And it's good to check, should this be an increasing line? Well, I look at my slope, I have a positive 3, which is increasing. My line is increasing. I know I'm in good shape. My solution is where? So to count x comma y, right? X comma y, we count left and right first. So starting at the origin, I go right 2, which is a positive 2, and up 1, which is a positive 1. So my solution is 2, comma 1. Number 3, we will have the same approach. We need to solve for y equals mx plus b. So one at a time, let's start with the first equation. X plus y equals 1. Line down the equal sign. I need to get y by itself. To make that happen, we will subtract x from both sides. Y equals, these are not like terms, so negative x plus 1. Y is by itself. That is all set. M equals negative 1 and b equals 1. So this will be my starting point for the y-intercept. I go to 1, make my point, and then to interpret negative 1 as a slope, I know that I can write that as a fraction, negative 1 divided by 1, so that'll be down 1, right 1. Down and right. Down 1, right 1, down 1, right 1. And again, it may seem a little tedious, but just take a second and get as many points on this line as you can. And we'll count in the other direction, starting at 1 again, up 1, right 1, up 1, right 1, up 1, right 1, all the way over. Using your straight edge or your ID, graph that line. The question, should I have a decreasing line? If I look at the slope of this line, it's negative, so I should have a decreasing line. My graph has a decreasing line, so I know I'm in good shape. Let's work on our second equation. 2x plus 2y equals 2. Process doesn't change. Let's solve for y. When I look on the right side, if there's something I can use addition or subtraction to move first, I want to do that. So ignore the 2y for right now. How do we move a positive 2x? Well, the opposite of a positive 2x is a negative 2x, so we'll subtract 2x from both sides. That leaves 2y on the left side. Now, this is why it's really important to not drop our variables, because if you dropped x, it would look like you could do 2 minus 2 is 0, and that's not what this says. This is 2 minus 2x. Those are not like terms. So I bring down negative 2x plus 2. And to finish solving for y, remember, 2y really means 2 times y. So what undoes multiplication? Division. So we will divide each piece by 2. This results in y equals negative x plus 1. Well, if I graph this, I look, same equation, negative x plus 1, negative x plus 1. So what we have here, if you were to graph this, you would end up with the exact same points. This is one line graphed right on top of the other. So you can represent that by these double arrows that I drew. So think about what this means. If every single line is shared on both lines, and lines go to the left forever and ever and to the right forever and ever, this is that special case of infinitely many solutions. Infinitely many solutions. And we're done with graphing. So the process doesn't change. For every single system, you have to make sure you solve for y first. Graph, my solution will be where these two lines intersect. You could have a special case, like in number 3, where I have the same line. Just a side note, remember, the other special case would be parallel lines, where the lines do not intersect. That would be no solution. So keep that in mind. Moving on to substitution with number 4, take a second to find your notes and figure out what the 3 titles are we going to give the work? Here, here, and here. For number 4, the directions say to solve the system using substitution. Now, I am told I have to use substitution. So there is no reasoning which is better. I'm specifically told a method, so we're going to use that method. Remember, for substitution, we have 3 concrete steps we're going to use. Solve, first sub, second sub. And try to space them out. If you write in pencil and you need to move one of them over, that's fine later on. But really spread them out, kind of like the beginning third of the page, the middle, and then over here on the far right. So to solve, I need one of these equations solved for either x or y. And if I look at my original system, nothing is already solved for. So now I want to work on making a good choice. I could solve this one for x or y, or I could solve this one for x or y. When I look, this positive y stands out to me because it's almost by itself. So we're going to choose that equation for the solve step. I'm going to write 2x plus y equals 5, and I'm going to solve for y. To do that, I'm going to subtract 2x from both sides. And I get y equals negative 2x plus 5. Notice that was very quick. I don't have any fractions in here. I'm in good shape. First sub, we're going to take the function you did not use yet, which is my second equation. 4x plus 3y equals 7. And I ask myself, do I have something to substitute in for x or for y? Well, when I look, this clearly says y equals. See this? Y equals. So that means that I have something to substitute in for y. Housekeeping, move over a little bit. Let's start writing farther to the left to give us some space. And where I see y, in parentheses, I will be substituting in negative 2x plus 5. And if I notice, now the only variable present here is x, so I can solve for x. Using your algebra skills, 4x will stay. We're going to distribute 3. 3 times negative 2x is negative 6x. 3 times positive 5 is a positive 15, equals 7. Combining like terms, I have 4x and negative 6x. 4x and negative 6x makes negative 2x plus 15 equals 7. We will subtract 15 from both sides. Keep this line going down the equal sign. So we have negative 2x equals 7 minus 15, which is negative 8. Divide both sides by negative 2. X will equal positive 4. Pay attention to your signs. Negative divided by a negative is positive. If by accident I treat this as a negative 4, my second sub will get me an answer, and if I were to check that ordered pair, it will not work. So watch your signs. My second sub, I've got x, I need y. So we're going to take this equation that says y equals, bring it over here. Y equals negative 2x plus 5. Where I see x, I will substitute in my value, which I now know is 4 for x, plus 5. Negative 2 times 4 is negative 8. Negative 8 plus 5 is negative 3. So my solution is 4 comma negative 3, and I'm done. So again, if I'm specifically told substitution method, go right to our 3 steps. Solve, first sub, second sub, and we're done. Number 5. Number 5 specifically says to use linear combination or elimination method. So I'm told what method. Let's use that method. We're going to ask ourselves first, do I have inverses present? Do I have exact opposites? Well, if we look at the x values, this is a negative 7x. This is definitely not a positive 7x. Same thing with the y's. I don't see like a positive 2y and a negative 2y, or a positive 4y and a negative 4y, which means I'm going to have to do some work to get my inverses. At first glance, I look at this positive 2y and this positive 4y. That catches my attention because right away I know that I can use multiplication to get this to be a positive 8y and this to be a negative 8y. So I choose to get my y's to cancel. If you want to work on x's, you're more than welcome. You would work on getting one of these to be a positive 56x and one of these to be negative 56x. So if you choose to do that, go ahead and we can compare final answers. For me though, I'm going to pay attention to these y's. So to make a positive 2y become an 8y, I know I need to multiply this by 4. And for my second equation, I need a negative 8y. So I will multiply by negative 2. Let's see what we get. Distributing in 4, 4 times negative 7x is negative 28x. 4 times a positive 2y is a positive 8y. Equals, remember, we still have to distribute 4 to this term on the far right here. So that will become negative 4. Distributing in negative 2. Negative 2 times negative 8x is a positive 16x. Negative 2 times a positive 4y is a negative 8y. And then last but not least, negative 2 times negative 8, positive 16. So now that I have finished my multiplication, I want this to be in a different color. Oh, that's not working. Now that I have finished my multiplication, let's check. Do I have inverses? Yes, I do. Positive 8y and a negative 8y will cancel. So line down our equal sign, line across. Let's linearly combine them and see what happens. Negative 28x plus 16x will be negative 8x. I know my y's are going to cancel, equals negative 4 plus 16. Hold on, that's not right. Ms. J is tired. Negative 28x plus 16x is negative 12x equals negative 4 plus 16 is 12. We're going to divide both sides by negative 12 to finish this up. We get x equals negative 1. Now that I have x, we need to go find y. Remember, we're going to substitute into one of these original equations. It does not matter which one. So I'm just going to choose the first one. Maybe you choose the second, that's fine. So negative 7x plus 2y equals negative 1. Where I see x, let's substitute in negative 1 plus 2y equals negative 1. This becomes 7 plus 2y equals negative 1. We'll subtract 7 from both sides. Two y equals negative 8. Divide by 2. Divide by 2. I get y equals negative 4. So my solution is negative 1, comma, negative 4. If I do a mental check, negative 7 times negative 1 is 7. 2 times negative 4 is minus 8 equals negative 1. 7 minus 8 equals negative 1. Check. Negative 8 times negative 1 is a positive 8. 4 times negative 4 is a negative 16. That does equal negative 8. So that's a quick informal check that you can do. Otherwise, you could write out both equations, formally plug in both x and y and solve. But now that we're getting good with our system, you could also run a quick informal check like we just did right here. Now with 6 and 7, notice the directions have changed. It specifically says use the most efficient method. So now you get to decide. So thinking back to our last set of notes on how to decide what is the best method, if I see equations that are both in standard form, meaning ax plus by equals c, ax plus by equals c, I know for sure that we will be using elimination. So for number 6, let's ask ourselves, do we want x's to cancel or y's to cancel? There's really no wrong answer here. You can choose either one. If I want my x's to cancel, I need to work towards a positive 6x and a negative 6x. If I want my y's to cancel, I need to work towards a positive 12y and a negative 12y. Because I see that I already have this positive-negative relationship, I am going to choose to work with the y's because it means I don't have to worry about multiplying by a negative. What I mean by that is if you chose to get x's to cancel, these are both positive, so nothing is going to cancel. I would have to multiply something by a negative value. Not bad. If you want to do that, go ahead. Working towards my 12s here, though, to get positive 3y to be a positive 12y, I'll multiply this top equation by 4. I need this to be a negative 12y, so I'll multiply this by 3. My new system becomes 8x plus 12y equals 48, and 9x minus 12y equals 3. I have my inverses now. I have my positive 12y and my negative 12y. Lines on the equal signs. Line straight across. Let's combine these. Smartboard is acting up a little bit here. Okay, so 8x plus 9x will be 17x. My y's cancel to 0 equals 52. Dividing both sides by 17. Not really working out how I thought it would. Pause for a second and see what happened. Who caught my mistake? I just found it. 48 plus 3. 51. Okay, let's try that again. 51 divided by 17 is 3. X equals 3. Again, as I mentioned in a previous video, right now for the skills questions, we are having these work out nice. So as soon as I got some crazy decimal, I went back and I looked. Remember that once we get into real-world systems, which will start with our next lesson, most likely we will always be getting decimal answers. So there's a time and place. For these skills-based questions, we're focusing on whole number results. Once we start real world, expect decimals all over the place. Okay, x equals 3, I need to go back and find y. It does not matter which equation you choose. I choose the first one. You could choose the second. We will get the same answer. 2x plus 3y equals 12. Where I see x, we will substitute in 3. Everything else stays the same. You can go ahead and pause right here and finish, and then we can compare answers. So I have 6 plus 3y equals 12. Subtract 6 from both sides. y equals 6. We'll divide both sides by 3. Y equals 2. My solution, 3, 2. Running that quick mental check again, here's x, here's y. So 2 times x, so 2 times 3 is 6, plus 3 times 2 is 6. 6 plus 6 equals 12. Check that out right there. First one's good. 3 times x. 3 times 3 is 9. Minus 4 times 2 is 8. 9 minus 8 is 1. Check. Let's take a look at number 7. When I look, I have a standard form, meaning I know I'll be using elimination. I need to make a choice. So I want my x's to cancel or my y's to cancel. If I want my x's to cancel, I have a 5x here. I could get this to be a negative 5x very easily. And I think that's the best choice, because if I want my y's to cancel, I'm going to have to work towards a negative 14y and a positive 14y, which would involve multiplying both equations, which is not horrible, but if I don't have to, let's not. So we're going to get x's to cancel by multiplying this by what? This is a positive 5x. I need this to be a negative 5x. So we'll multiply this top equation by negative 5. That will get me negative 5x, because negative 5 times x is negative 5x. Negative 5 times a negative 2y is a positive 10y. And then last but not least, negative 5 times negative 1, positive 5. We didn't touch the second equation, so let's leave that alone. 5x minus 7y equals 4. Lines on the equal sign, line straight across. My x's will now cancel. 10y minus 7y is 3y. 5 plus 4 is 9. Divide both sides by 3. Y equals 3. We're halfway there. We have y, we need x. So choose which equation you'll substitute this in for and actually find x. So pause the video here and we'll compare answers when you're done. I'm going to choose the second equation. So x minus 2y equals negative 1. Where I see y, I will be plugging in 3 in parentheses. Equals negative 1. So I have x minus 6 equals negative 1. Last step would be to add 6 to both sides. I get x equals 5. So my solution is 5, 3. Again, we can run a quick mental check. Here's x, here's y. Looking at my original system, x is 5. So 5 minus 2 times y is 2 times 3 is 6. 5 minus 6 equals negative 1. Check. Informal check of the second equation. 5 times x is 5 times 5 is 25. Minus 7 times y is minus 7 times 3, which is minus 21. 25 minus 21 is 4. Check. And we're all set. So your assignment is to make sure that this second page, both sides, is done. I would like to just walk through a strategy check with you, so to speak. Number 8, what method will you use? I see that one of these is already solved for y. This will be substitution. So number 8 is substitution. Solve first sub, second sub. So solve first sub, second sub, where this one is already solved for you. Y equals negative 2x plus 6. Again, just focusing on the setups. So you finish 8, okay? Number 9, substitution or elimination. Well, when I look, this one is solved for x. So again, this again will be a substitution question. Use substitution. Number 10, I definitely don't have a standard form system. And what I mean by that is I don't see this clearly. Not even close. So because I don't see this, this will be a substitution question, and I'm going to help you get this one started. So for substitution, I know my steps will be solve, first sub, second sub, Let's reason on which of these is the best to solve for. This one is almost solved for y. This one is almost solved for x. When I look at the top, to solve for y, I will have to divide by what? I'm going to have to divide by this 8. Is 6 divisible by 8? No, it's not. So technically you could solve for y, but I'm going to end up with a fraction. If I solve this one for x, I'm going to have to divide by what? I'm going to have to divide by a negative 5. And if I look, is negative 15 divisible by negative 5? Yes. Is 20 divisible by negative 5? Yes. So we're going to choose to work with this second equation for the solve step. And my recommendation to you is to solve for x. To do that, we'll divide by negative 5. And I will get x equals negative 15 divided by negative 5 is 3. 20 divided by negative 5 is a negative 4. I've got x, and you're good to go from here. Go ahead and use the equation you didn't use yet. 8y equals 6 minus 2x, and you guys can rock it out from there. Do your substitution. This says x equals, so I have something to substitute in for x, and you can keep going. Number 11, look in your substitution notes. This is a break even special case. This is going to be a substitution question. Now I just realized some of you have turned in your substitution notes, so I will help you start this. Solve. First sub, second sub. Now they're both solved for y, so it doesn't actually matter which one you pick. So I'm just going to choose to put the first one under here. First sub, what equation did you not use yet? The second one here, so y equals 5x minus 9. The rules don't change. This says y equals. So where I see y equals, so where I see y, I will be substituting in negative 3x plus 7. Bring down the rest. And we now need to solve this. This is a negative. We need to solve for x. Number 12 is a standard form setup for both equations. So I know that this will be elimination. I also have standard form. So this will also be elimination. So 12 and 13 are both elimination, and that rounds out your assignment. So your job is to complete numbers 8 through 13. And please remember to send me any and all questions on Remind. Have a great day, everybody.